Question 13 is another pulley question. So we've got this pulley, it's got a mass that is 3 kilograms on one side and a mass that is m kilograms, and they tell us that m is less than 3. They're attached to the end of the light inextensible string, it goes over a smooth pulley, particles are held in position, and it's released from rest, and the initial acceleration of the particles is 3/7g. Find first the tension in the string. Well, let's start off as usual by labelling all of the forces that we've got. So down here we'll have a force of 3g and the tension going up in the string there. Here as well we'll have a force of mg and the tension going up. Now in the question they told us that m was less than 3, and that is because we need to know whether the pulley will be moving like this or like this. Now if m is less than 3, that means that this side over here, the left hand side, is heavier, so the 3 kilogram weight will be going downwards and m will be going upwards. So I know that the acceleration is upwards on this side, and they told us that's 3/7g, the acceleration, whereas on this side it's downwards, so 3/7g downwards over here. And first what we're trying to do is we are finding the tension in the string. Well, what we can do is we'll just focus on the 3 kilogram mass, so imagine I'm cutting off and just focusing on this section here. And we know that if I resolve downwards, because the acceleration is downwards, the resultant force will equal the mass multiplied by the acceleration. Well, let's resolve downwards then. Down I've got 3g. I need to take away the tension because that's going upwards, and that is equal to the mass, which is 3, multiplied by the acceleration, which is 3/7g. Now if I tidy this up a bit, I get that 3g minus t is equal to 9/7g, and then I can say that t is equal to 3g minus 9/7g, and we just need to do 3 take away 9/7, which is 12/7g newtons. That is my tension there. Obviously you could type it into your calculator because you know g is 9.8, but it's a bit nicer to just leave it in terms of g because then we don't have any rounding errors. So we found the tension. Next we want to find the value of m. So for part B, I'm going to this time just look at this side. So I'm cutting off this section here, and I'm going to do the same thing. If I resolve upwards, I know that the resultant force equals the mass times the acceleration. Well, the resultant force upwards, I've got t. I need to take away mg because that's going downwards. So t minus mg is equal to the mass, which this time is just m, times the acceleration, which is 3/7g. Sorry, I almost wrote a 7 there. 3/7g. Now we know that t is 12/7g, so let's sub that in. 12/7g minus mg equals m 3/7g. And I want to work out what m is, so let's bring all the m's onto one side and everything else onto the other side. So if I take that over to there, I've got 12/7g. In fact, let's cancel out the g's because everything's got a g in it, so it can all disappear. 12/7 is equal to, I'll take that over to the other side, I've got m 1 plus 3/7 divide by 1 plus 3/7, and we'll get that m is equal to 1.2. Oh, just missed that off the bottom there. Kilograms. So really, once we've got to that equation, it's more about just rearranging to work out what m is going to be than any real mechanics needed for that bit. 1.2 kilograms.